Welcome to hopefully a short video just going over some terminology that we should know about functions. These are kind of the big ideas that we'll cover in the video. Some are new, some are going to be slightly review. And just a very brief intro, our first slide here will just talk about what is a function. I'm going to spend some time in class talking about this actual definition, and at that time I'll probably just run through some of these pictures and things, but I'll just put this up here right now in case you wanted to maybe look it over. In the end, the big thing for a function that you guys might remember is it needs to pass the vertical line test. So if we just look at the pictures on the bottom, you guys know from a parabola that I could draw vertical lines in here, and it's only going to touch it once for every vertical line. That means it's a function. But over here, our sideways parabola, when I put in a vertical line, it's going to touch twice, and that's a no-no. So the easy thing to remember is that we simply need to have it pass the vertical line test, but I still like to talk about this big definition, and I'll take care of that in class. So domain, we have this implied domain. That's what we find from algebra. That's what we'll do in this part of our course. And then the relevant domain, when we start looking at applications, then we start thinking, do I need to restrict that domain anymore because of the use that we're looking at? For now, you should be able to find the domain for simpler ones from the equation, thinking through the parent function in BHAK, and then for some more difficult ones from the graph, and basically the same thing for range. We want to be good at doing it algebraically, but also from the graph. So just a couple quick examples here. If we're going to look at the function 2 over x, I'm going to show you a graph, but I want you to be able to think through this. This is really 1 over x and then times 2 in front of it, 2 times 1 over x. So it's our basic reciprocal function that has been vertically stretched by 2. And so if we were just to look at the picture, we would say that for all the x values here, we're generally doing okay, but there is a vertical asymptote right here. And so when x equals 0, we're not going to get anything. For the range, every y value is covered, but now we have a horizontal asymptote right here where there's a blank y spot. So for both domain and range, we'd say it's all real numbers except 0. Now, one other thing that we could do with the domain, we could look at, in this case, the fact that the denominator can't equal 0. So that's another way to get that. And we're going to go through some examples of that in class. Okay, for the range, I would probably focus more on just thinking about the parent function and how BHAK will change that. So if you knew that 1 over x, there was an issue when y equaled 0, that's still going to be true for 2 over x. This notation right here is what we call interval notation. And just a quick summary of it, it means that we go all the way, for our x values, we go all the way from negative infinity to 0. When we don't have a closed bracket there, or square bracket, we say we're not going to include 0. So over here we're not including 0, again we're going all the way to infinity. That's a way of modeling on our number line what values work. For range, now we're going to start way down here. Every y value, it's going to work from negative infinity all the way to 0. Because it's a parenthesis, it's not going to include it. We pick it up on the other side, so from 0 all the way to infinity, those y values work. Okay, another example, square root of x plus 2. Again, we can look at a picture of it. BHAK is going to tell you to take square root and shift it left 2. So I want you to be able to do that on your own, not having me supply you with a graph. You should be able to come up with this on your own. And now looking at the graph, the domain would be from 2 and above, and the range would be from 0 and above. But another thing we can do with domain, we have to realize that the stuff under the square root can't be negative. And so by thinking about that, we can even show some algebra work for that. X has to be greater than or equal to negative 2. Okay, so we can think through BHAK. We can also do some algebra stuff for domain. For range, we really have to focus more on the parent function and how things have been moved around. So again, we have interval notation. We said the domain was negative 2 and greater. This means we include negative 2 and we go all the way to infinity. So negative 2 and greater. The square bracket means we include that 2. Range, we have to realize we're talking about y values. What we set up here, it's going to be 0 or bigger. So this includes 0 and says anything bigger than it would work. We can review this interval notation in class if that would be helpful. Okay, continuity is our next example. The easy way of thinking about it is if you can trace from left to right without picking up your pencil. And we'll start by using our graph, but again, if we think through some of these functions and can get a sense of what the picture looks like without them providing it for us, At some point we'll be asking about that too. So again, a lot of terms here. This is continuous. The other ones are not continuous, or they have some sort of discontinuity. A removable discontinuity just means we have an open circle that we could fill in and plug. But these other ones are types of non-removable, where we couldn't just fill in a little dot and say all of a sudden it's okay. So let's think about what x plus 3 over x minus 2 looks like. You probably don't know. When we finish our second unit, you'll have a better use for that. So right now, I simply have to give you a graph. Here's the graph of x plus 3 over x minus 2. Pretty clear here that there is a big jump, and just from that it would be discontinuous. So again, you're not expected to know how to get this graph right now, but after our next unit you will be able to do that. This one is x plus 3 times x minus 2. I could ask you this right now. Hopefully you recognize if you FOIL it together you get a parabola, and parabolas are continuous. Okay, you can go from left to right without picking up your pencil. This one is a little bit more difficult. So if we were to graph it, it would look like a line. If we think about it a little bit more algebraically, if I were to factor apart the top, I get x plus 2 over x minus 2. And the x minus 2 on top and on bottom will cancel off. We're just left with the equation of a line. However, there is a hole at x equals 2. That's what this part would tell us. And I think that you guys have talked about that in advanced algebra. But if any of that doesn't quite make sense, let me know. But because there's that hole there, we have to say for now it's discontinuous. Again, in our second unit, we're going to go over a lot of these kind of functions. So it's not something that you're required to know right now. Hopefully it's a little bit of review, and we'll hit it again in our second unit. Okay, increasing and decreasing is our next set of terms. To do this, you basically need to look at the graph or think about the graph. Always think of moving from left to right. As you go from left to right, if you are going uphill, you're going to be increasing. If you're going, what is this saying? I'm not sure. It goes downhill, I guess. It must have cut off by the picture there. So if it's going downhill, it's decreasing. And if it's constant, it's perfectly flat. So you have some different pictures that will help you visualize that. Okay, an example, x plus 2 being squared. We know it's a parabola. We can think of the original parabola being shifted left by 2. And so as we go from left to right, it's going to be decreasing until it gets here, and then increasing. A lot of times we try to describe that using interval notation. So these are x values from negative infinity to negative 2. So from way over here all the way to negative 2, it was decreasing. And then from negative 2 all the way to infinity, it is increasing. This is a list of x values where that's occurring. X squared over x squared minus 1. This is not one that you should know how to graph right now. Again, after our second unit, that will be easier. If this was the graph, we could say from left to right, it is increasing here. It's also increasing for this little piece, but there's a little jump there. Now it's decreasing, and it's decreasing there too. So as we summarize that, again, these are x values. It's going to be decreasing from x equals 0 all the way to 1, not including the 1 because there's that vertical asymptote. On the other side of 1, it picks up, and it's decreasing all the way to x equals infinity. So that's what this part is describing. Increasing is the same thing. It's just going to start way on the left side, though. So increasing, decreasing always go from left to right. Okay, being bounded some way is also a new term. If there is a lower bound, there's going to be some horizontal line that the graph never goes below. We want to know what that number is. Upper bound, there's some number that, or some horizontal line above it, and bounded means there's both. So lower bound and upper bound, if both seem to happen, then we just say it's bounded. So again, we go back to our example of x plus 2 being squared. There is obviously a place that it never goes below. That's, in this case, the x-axis. We'd say it's bounded below by the x-axis, or as a lower bounded below by y equals 0, or as a lower bound of 0. Any of those would be fine. Local and absolute extrema. A max is just the top of a hill. A min is the valley. Those are just local things. So there could be lots of those, but the absolute extrema, or the absolute max, the absolute min, that's the highest of the highs or the lowest of the lows. So this one you would have to graph on your calculator, x to the 4th minus 7x squared plus 6x. But we could call this this part right here could be a local min. This would be a local max. and this would be a local min. And then it's going to keep climbing on either side. This is special though because it's the lowest of the lows. So that's actually the absolute min right here. This is not the absolute max because it gets way higher on the right side and way higher on the left side. So again, you need a calculator to kind of figure this out. We will review a little bit how we can use our calculator to do that for us. But if it was more of an easier function to work with, something that we could deal with BHAK and know something about the parent function, I'd expect you to know how to find these without a calculator. Okay, and then our last topic is probably the toughest, what we mean by symmetry. So it can be symmetric with respect to the y-axis. Think of a parabola. We can reflect that over the y-axis, that we have this mirror image. And the big thing here is that if I move the same amount to the right as I do left, I'm going to go up the same height there. So on a t-chart, if we look at 3, we should go up 9, and at -3, we go up 9. We have that mirror image. Algebraically, we're going to say that f of -x should equal f of x. We're actually going to be testing for this. And if that happens, we call this whole idea an even function. Okay, but f of -x should equal f of x. It means if I go left versus right and I look at their y values, they're exactly the same. The other one that we look at is if it's symmetric with respect to the origin. That means it has rotational symmetry. So x cubed might be a good one to look at. For this one, if I just look at the table and I look at 3, if I plug in a 3, I get 27. If I plug in -3, I should get the same number, but the opposite symbol or the opposite sign. So in this one, when I plug in f of -x, so maybe f of -3, I get -27. How does that appear, or how does that compare to f of 3? Well, it was the opposite. So we say it equals -f of x. So when that happens, we have an odd function. Again, this gets a little bit more confusing. I'm going to show you 2 ways that we would kind of prove it, or 2 examples of how we prove it. But again, this is brand new, and it probably will take a little bit of practice to totally understand. So if we were to look at the function x squared plus 3, we can visualize what that is using BHAK. But to actually do the test, we say plug in a -x. So what is f of -x? We get -x being squared plus 3. And now we're just going to simplify that. -x squared, it really gets us positive x squared. We still have a plus 3. And that's the same thing as f of x, the original. So when we start out with this and we get f of x, that means it's an even function. You can probably see that just from the picture. It's got that reflection symmetry across the y-axis. If we compare that to x cubed plus 3, well, now it doesn't have that reflection symmetry, and technically it doesn't have that rotation symmetry either. So if we went through and did the test, we plug in a -x, okay, so -x being cubed plus 3. If I were to simplify that, -x being cubed gets me x cubed that is negative. Think about that for a little bit. And this is not related to either the original or the opposite. So this sign has changed, this one has not. If we have that issue where some have changed and some have not, we have to call it a neither. And then this one, x cubed plus 3x, that one looks like it has more rotational symmetry if we go through the test again. Okay, we plug in a -x. So over here, if we were to say -x being cubed plus 3 minus x, if I were to start simplifying that, I get x cubed, that's negative, and then also minus a 3x. Notice that every single sign has changed there as we compare it to the original. Now everything's negative. So that's your sign right away that it's going to be odd. But if you want to go through the algebra, you can just factor out a negative symbol from both parts. Now this is the original, so really you have -f of x, and that's algebraically the way that you prove that it's an odd function. So again, we'll probably have to go over those in class, but hopefully that at least shows you the general method that we would use. So in this video, we went over these terms. Hopefully that makes sense somewhat. Jot down any questions you might have, and be prepared to go over a lot of questions in class, book work, to kind of reinforce some of these things.